I did.
Okay, so last week we started looking at our common polygons and we looked at the perimeter. And one of the things that we did was that we looked at the perimeter of composite shapes like this one, if you remember. And if you remember some of the dimensions, that means the measurements were missing. But you're always given enough information to find them. So we're going to look today at area, okay? Now, who can tell me what area is? Marlo?
The inner of the shape, like the inside.
Okay, the inner of the shape, yeah. Can anyone give me another definition?
How much space is inside the shape?
Very good, right. So area, let's write the definition. Area is the amount of space a shape takes up or covers, okay? So area, when we were looking at perimeter was one-dimensional. So we measured it in millimetres, centimetres, metres, etc. because it was one dimension. It was just the outside of the shape. Now, area is the amount of space that the shape takes up. So what dimension is that? How many dimensions? Chase?
I just was going to say it was squared.
It's squared, yeah, because it's two dimensions. Because we're looking at this dimension and that dimension. So area is measured in millimetres squared or centimetres squared or metres squared or kilometres squared. And there's one more measurement that is used to measure really big areas, and it's 10,000 square metres. Does anyone know what it is? It begins with an H.
Hectare square?
A hectare, yeah.
Hectare.
It's just called a hectare. It isn't squared, actually. It's just called a hectare, okay? So a hectare is 10,000 square metres. So if we look here, we've got a square, another square, a rectangle, and a composite shape. So, what are the dimensions of this square called? How would you label them?
Like length and width.
Right, okay. Would you label them two different things?
Oh no.
Why not?
Because all sides are the same.
Because they're the same, that's right. So, we can call it L, and if that dimension is L, what will that dimension be?
L.
L also, that's right, because it's the same, isn't it? Now, the other way it might be labelled is S for side, that's right, okay? But we'll call it L today. So, the area, how would I find the area of that shape? Mackenzie?
L times L.
L times L, okay. L times L. Now, we have just finished our algebra topic. How do we write a pronumeral times a pronumeral? Because really, we're using a pronumeral here to stand for the length. We're using L as a pronumeral here, algebraically. So how do we write L times L? Cameron?
Is it 2 brackets L times?
No, good try. Alex?
2
No, that would be L plus L, wouldn't it? 2L would be L plus L.
It'd be L squared.
L squared, well done. L squared. So, the area of a square is L squared, or if it's labelled S, it would be S squared. That's right, okay. Now, if you look at this square that I've drawn, how many units long is it? And how many units high is it?
9 or like 3.
Yeah, so the L is 3 units, and the L here is 3 units, okay? So if we put that dimension into our formula, we've got 3u times 3u, okay? What will that be?
9u.
9u what?
Squared.
Oh, well done, 9u squared. 9 units squared. So what we've done is we've multiplied that side by that side. But can you see, because we have done algebra, why it's units squared now, because u times u has to be u squared, doesn't it? So a centimetre times centimetre has to be centimetres squared. So that's why it works, because it's algebra, you know, and I know, you know, I said that I love algebra, but it's very useful in lots of other topics. Okay, let's have a look at this square then. So how do I know it's a square, first of all? Marlo?
It's not like different, like.
Mackenzie?
All sides are the same.
How do I know?
Because of like the line.
Yeah, very good. So there's a little line here, one here, one here, and one here. That tells us that the dimensions are the same. So let's give it a dimension of 7 centimetres, say. So we know then, don't we, that if that side is 7 centimetres, so's that one, so's that one, so's that one. What would the perimeter be? Be careful here. Remember what the formula was. Ashi. Right, the perimeter. Jack.
It would be 28 centimetres.
Well done. It would be 28 centimetres. Would they be squared? No, because it's a distance, isn't it? And this is when you start doing area, sometimes you mix it up with perimeter again, which is why I asked you about the perimeter. So, if you remember, when we were doing it last time, I gave you 3 things. We do the formula, the values, and then the calculation. So we always write the formula first. So what is the formula for the area of that square? The formula. Tyler.
7 times 7?
The formula. Remember, a formula has to work for any square on the planet. You've given me the values. What's the formula? Emma?
Length times width.
For the square. Are those distances different? Would we give them different letters? We wouldn't, would we? So what's the formula for the area of the square?
Length times length.
Yes, which is... We've done it in the other one, look, just look.
Oh, length cubed.
Yeah, length cubed. Why would it be cubed? That would be if it was volume.
Squared.
Squared, length squared. So it's length squared. Okay. Or L times L. L times L is fine. It's just that that really means L squared. Now, Tyler, what are the values that are on the actual square?
7 times 7?
Yeah, 7 times 7. Because this one here, the formula, that will work for any square on the planet. 7 times 7 is this particular square. Do you see the difference? So the formula works for anything, any square, but then the values are this particular square. So what is the area, Ashi, of that square?
49.
Well done, 49 centimetres squared. 49 centimetres squared. And if you actually marked off the 7 centimetres and marked off the 7 centimetres that way, you would see that there would be 49 little squares. That's why I did it here. Look, I marked off the 3 and the 3, so you could see that there were 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now, so that's your square. You do L squared. What's this shape? Bryce? A rectangle. How do you know it's a rectangle?
Because the 2 lines match up so that those 2 lines are parallel, and then the other 2 lines are
Yeah,
parallel.
so we know that these parallel lines are equal and these parallel sides are equal, so we know it's a rectangle. Okay? Now, let's put some dimensions on it. Oh, no, let's call that one L. And if I call that one L, can I call that one L?
No.
No.
Why not? Because it's not the same. And in algebra, you can't give the same letter to something that's different. So what should I give it, Emma?
A different letter.
Yeah, and you gave it last time, so
Length times width.
well done. W. Let's call it W. So the L is the length and the W is the width. Okay. Now, it's pretty similar to the square, really, in how we find the actual area. But who thinks they could tell me what the formula might be, algebraically? Go on then, Lachlan.
Is the 2 times brackets L plus W?
That's the perimeter.
Oh,
Would it be L plus W times 2?
Right, that's the perimeter.
L times W.
L times W, yeah, that's right. L times W. And how do we write that algebraically? What don't we need?
The multiplication.
Yeah, so what will we write?
L,
LW, that's right. Now, I'm just going to mark this off like this, just so that you see why it works. So that side is 4 units and this side is 3 units. So, we've got the formula, which is L times W or LW. And now we've got to put the values in. So what are the values for that particular rectangle? So remember, this will work for any rectangle. These are for that particular rectangle. Cassidy?
3 times 4.
3 units times 4 units. That's right. 3 units times 4 units. So 3 units multiplied by 4 units. So what does that come to?
12.
Yeah, 12 what?
Square.
Units squared, that's right. 12 units squared. So if there were centimetres, it'd be 12 centimetres squared. The reason being that that is 1 square unit, isn't it? Because if that's 3 units, that will be a U, and that will be a U, won't it? Do you see? So that will be U squared. For this one, if that's a U and that's a U, what will that be?
A U.
U squared, that's right, U squared. Each of those is a square unit or a unit squared, okay, which is why it's 12 units squared. Now, this one is slightly more complicated. We did this last week when we looked at the perimeter and we found, didn't we, the unknown values. So we've got 15 centimetres here. So what will this dimension be? 15 centimetres also. Okay, if this dimension is 6 centimetres, what will this dimension be? 6 centimetres. And this one will be 6 centimetres, and this one will be 6 centimetres. Okay? Now, we've got that one, and that one. This is where we highlighted them last week. So you highlight that one, and highlight that one. And what do I highlight then? The 12, that's right, the 12. So those 3 highlighted dimensions are the same as 12 centimetres. Remember we did that last week. So that one, and that one have to add up to 12. So how long are those ones? 4 centimetres, that's right, 4 centimetres. 4 centimetres and 4 centimetres. So, we could now find the perimeter, couldn't we? Because we could just add, and we'd find the perimeter. But how are we going to find the area? What do you think you could do? Go on then, Bryce, what would you do?
You could split it up into like little squares and rectangles where it turn and bend.
Very good, you could split it up in...
Areas up.
Yeah, because we know how to find the area of a square or a rectangle, we could split it up into squares or rectangles and do each one individually. So let's split it there and there, okay? What are the dimensions of this rectangle here?
15 centimetres by 4 centimetres.
Well done, 15 by 4. So 15 by 4. What's the dimension of this rectangle? 15 by 4, because it's the same, isn't it? 15 by 4. Now, what about this little one in the middle? Well, it's obviously 4, isn't it? But how deep is it, and how are we going to find that out?
Ooh.
Go on then, Chase. Can you explain how?
So because it's 15 centimetres on the side
Yeah,
and it's 6 on like the inner bit,
yeah.
which equals 12, so the middle bit has to add up to 15, so it's 3.
3, well done. Okay. So that little bit there is 3 centimetres, and we find that the same way with the highlighter, because if you look at it, you've got your 15 here, we'll highlight that in green, and then you've got 6 and 3 and 6. So obviously that little bit has to be 3. So then, we've got 15 times 4, and we've got to add that to 4 times 3, and we've got to add that to 15 times 4 to find the area, haven't we? Because we obviously know that we multiply the dimensions to find the area of the rectangles. They're all rectangles, actually. So, what is 15 times 4? Yeah, use your calculator. Absolutely, use your calculator. Bryce? 60. What's 4 times 3?
12.
12. And what's 15 times 4?
60.
60. Okay, so what does that come to?
Would it be 132
132 what?
squared?
Centimetres squared.
Sorry.
That's right. Okay. Stop there then.